This is our last lesson in our ProbStat unit, and this will cover surveys or studies is another way you could think of this, and this would be on the very last page of the notes, and that comment is for students in the 2020-2021 school year, which is the year that I am recording this video. So if you are watching this in another year, disregard that unless you've been told otherwise. So we, in the last lesson, we talked about different sampling strategies, convenience, random, systematic, and self-selected ways of getting a sample out of a population. We use sampling when we conduct studies, and there are three main study methods. So sometimes when students are answering questions on this, they actually confuse the two, and so you might be asked for what sampling strategy, and students will give the study or ask what study it is, and they'll tell me what sampling strategy was used. So do make sure that you flip the page over and that you're clear on the different things here. So first kind of study is an observational study, and that is defined as a study in which we measure in a way that doesn't affect the set that we're measuring. So we measure in a way that doesn't affect the set. In other words, you just watch them or observe, hence the name observational. So you would just observe, you're just watching, and you're watching in a way that doesn't affect what's happening. So if you, teachers, we get observed a couple times a year, and an administrator walks into our classroom, and that's not strictly observational, because the moment an administrator walks in, there are things in the classroom that shift. So sometimes students are better behaved when there's an administrator. I've had the problem where students that are normally chatty and will answer every question, as soon as the principal's sitting in the room, suddenly they don't want to say anything. Sometimes the teacher will change what the teacher does. And so just their watching does affect the set. Okay. So it would not strictly be observational. It's the best you can do, but, because you can't, unless you want to spy on a class. Yeah. And thankfully that doesn't happen. I don't think that happens. But anyway, you measure in a way that doesn't affect the set. You just watch. Then you have something called a controlled experiment. This is what you would do in your science classes, and if you were studying sociology and doing studies in that vein. In a controlled experiment, the sample is divided into two groups. One group receives a treatment and the other does not. And in the end, you compare the two groups. And I know we're tying a lot of stuff into COVID and the vaccines, because that's what's happening now. And a lot of this stuff you should be, if you're paying attention, you can see it play out right in front of you. So there was a news article not that long ago about some reporter, or no, it was a doctor. It was one of the doctors that goes on the news shows. I don't remember what her name was. And she had agreed to participate in the Johnson & Johnson trial for their vaccine. And she had gone back. She did get the vaccine, but during the trial, she was given what was called a placebo. So what Johnson & Johnson did when they did their trial is they have two groups of people. One group got their vaccine. The other group got a shot, but there was nothing in it. And so they didn't know, she did not know at the time whether or not she was vaccinated. So that's called blind. Okay. It means the participants don't know which group they're in. And then they track those groups for a certain amount of time. And then they would compare how many people got infected with COVID, how serious was the the infection, did they end up in the hospital? Was it mild? And they compare the two, and that gives them a measure of how effective the vaccine is, because hopefully the people who got the real vaccine had fewer infections than the group that didn't. And then what they did with her was they eventually, like when the study was done, they told them which group they were in, and she found out that she was in the placebo group, and then they offered her like the vaccine, which she did take. But she participated in that. Sometimes in a controlled experiment, there's what's called a double-blind study, and that's where the researchers don't know which group people are in the event that like maybe a researcher for Johnson & Johnson really wants the results to come out a certain way. And so they might do something in their interpretation of the numbers based off their personal bias. So a double blind is when neither the participants nor the researchers know who's in which group. Now, obviously someone does, but it's not the people doing the research. So like the person that was giving the shots out, like they know, they have the record of who is in which group, but not the actual scientists that are doing the research. And then after they've concluded the study and they have all their data, then it's revealed, okay, like you sift the people into the group. So there are ways to really try to eliminate bias in that. And the third one is a survey. And a survey is just every member in the sample is asked questions. And that opens up whole new opportunities for bias, because you can ask good questions or bad questions or rigged questions. So, in an example of a bad question, just the other day in our class, I had the worksheet and I had the question, this was for the box and whisker plots. And the question, I don't remember how it was phrased, but it was like, how many numbers are in the data set? And about half of you read that as when you list the numbers, how many numbers will be in the list, which is what I intended to ask. And about the other half of you read it as how many different ways can you roll the die, which is not what I intended to ask. But in hindsight, like after fielding a lot of questions on it, I realized that was not a great question for me to ask. I knew what I meant, but it really was not clear to you guys what I meant by it. And so when you're writing questions and asking questions, that can be an art in and of itself. All right, so this is an example from the textbook. Which type of study method is described in each situation? Should the sample statistics be used to make a general conclusion about the population? In other words, is there potential for this group of stats to be biased and it actually doesn't represent the population? So again, you're not looking at what sampling strategy was used. You're looking at what study method was used. So first one, researchers randomly choose two groups from 10 volunteers. Over a period of 8 weeks, one group eats ice cream before going to sleep and the other does not. Volunteers wear monitoring devices while sleeping, and researchers record dream activity. This is an example of a controlled experiment. The statistics for this study are based on such a small sample that the findings are unreliable as a general conclusion. And that comes from here. They only had 10 volunteers. That's not a big enough sample to be able to draw general conclusions. So again, like bringing it back to like the vaccine trials, when they're testing it out, they start with a super small group. That's like your early phase stuff. And they start with a really small group, and that group they're looking for like serious stuff happening. And then they make the groups bigger and bigger. So by the time they get to their final phase of trials, they're up in like around 40,000 I want to say 40,000 is like the ballpark number of the people that would participate, because they need a bigger group, because there's lots of things that can happen. And if you only have like 10 people in your group, you're not going to catch enough stuff. So in that example, the sample was too small. Students in a science class record the height of bean plants as they grow. This is an observational study. because just recording the height does not affect the plants. I mean, unless you're digging a ruler into the dirt to record the height, and don't do that. The statistics may provide a general conclusion about the growth rate of a bean plant. However, soil type, amount of sunlight and water, fertilizer, and other factors could affect the growth rate. And what that is a recognition of other variables. So if your population is all bean plants, and these bean plants are being grown like inside in, fertilized soil, then the conclusions might not apply to bean plants growing in a field, or bean plants growing in another part of the world. Okay. And so there's a lot of other variables in there. And notice that they do kind of hedge the question. They may provide a general conclusion, but it depends on this. And that's where a lot of these answers are going to be kind of gray and vague. You just need to be able to identify possible sources where something might not be right and explain your reasoning. Last one here. The student council members ask every 10th student in the lunch line if they like the cafeteria food. This is a survey because you're asking people questions. The results are not reliable in this case because people waiting in the lunch line are more likely to enjoy cafeteria food than those who brought their lunch from home. Not guaranteed. Okay. I ate the school lunch for years and I was never a huge fan of school food. But I would eat it. I liked it okay, for however long it was that I ate it. Eventually I stopped. But the idea is the bias. You're going to overrepresent people who like the cafeteria food and underrepresent the people that don't. All right, here's one for you to try. A pharmaceutical company asks for volunteers to test a new drug to treat high blood pressure. Half of the volunteers will be given the drug and half will be given a placebo. The researcher will monitor the blood pressure of each volunteer. Which type of study method is the researcher using? And should the sample statistics be used to make a general conclusion about the effectiveness of the drug in the larger population? And explain. Pause the video and in your notes, write some stuff so that I can see that you actually paused it and tried to do this problem. All right, so what you should have written down is controlled experiment for this one. This is because you've got the different groups and then you're going to compare the different groups. Okay, don't be confused with sampling strategy because volunteer, you might say, oh, this is a self-selected sample. Yeah, it's that too, but that's not the question that you were asked. You were asked what study method was it. Now, in terms of should the sample statistics be used to make a general conclusion about the effectiveness of the drug in the larger population, I actually wrote in my notes, maybe it depends on who volunteers. The deal with this is that people with high blood pressure or people whose blood pressure has not been controlled on other medications might be more likely to volunteer to test out a new drug because the existing ones didn't work. And so maybe they're hoping this one will. So you might be dealing with a population that has more severe blood pressure issues than the general population. And so there might be some bias there. If you got a group that was all men who volunteered for this, that would definitely be a source of bias because drugs do affect men and women differently and you would need to have them represented. Other issues might be people of too much of one age group or one ethnicity. So we know that certain race or ethnic genes, like that there's differences in the likelihood of maybe certain reactions in some people. And so it really depends on who those volunteers ended up being. All right, sometimes the phrasing of a question can bias the question. I mentioned earlier the example from our class, even where it wasn't a biased question, it was just an unclear question. So writing questions can be difficult. Like you think you're like, I got this great question here, and then you go ask it to people and you realize it wasn't great. So sometimes the phrasing can actually bias the question. This means that question is designed to get a specific response, or it's designed to like trap people or get people to answer a specific way. So for example, suppose I want to know if students prefer driving to school or taking the bus. I can phrase the question as follows. Do you enjoy the freedom and flexibility of driving to school, or do you prefer to take the bus? That question, the way that it's written, is intended to get students to answer that they prefer driving. Because you get freedom, you get flexibility. You can, if you got a senior, you can leave early. You can go to work on your way home. If you got a job, you can go from school to work and then go home. You don't have to detour other places. It's great. Second way you could ask the question is, do you appreciate the convenience of riding the bus, or would you rather deal with the craziness of the student parking lot when you drive? Because it can get crazy. A couple years ago, we tried the new drop-off pattern, and that was definitely very crazy. And there are definite advantages to taking the bus. It comes to your house or to your neighborhood, and you get on it, and you don't have to pay insurance on the bus, and you don't have to pay for gas for the bus. And if your bus is late, you get a free late pass, so you are not marked unexcused tardy. You can be marked excused tardy, and you don't accrue tardies towards an in-school suspension. So there are definite perks to taking the bus. And that question is tilted towards getting people to see what those pros are. And the third one, do you prefer taking the bus or driving to school? That's not a biased question there. Now, I could bias it by my sample. If I were to go to the bus drop-off zone and ask that question, I would get different answers than if I went to the other side of campus where we have like the entryway to the student parking lot. So that would be like taking your convenient sample. So you can have bias embedded in the question itself. Hot button social issues will also use changes in phrasing and vocabulary to make their views more appealing. And the example that I use with this, and this is not like intending to be like political or anything, but it's just an example of how people phrase things. So there is no group that is pro-abortion or anti-abortion. Okay, so this is definitely a hot button issue, okay, which we're not going to get hot button about it. But people don't use that because people don't use those terms. If you are in favor of legalized abortion, you would probably describe yourself as pro-choice. Because who doesn't want choice? Choice, freedom, good things. Okay, so you're taking your viewpoint and you're associating it with something positive. People not in favor of abortion use the term pro-life. So if you are not, you would probably describe yourself as pro-life, because who's not in favor of life? Life is a good thing. Don't we all want to be pro-life? Now, these are the words that people use to describe their movement. Now, people in the pro-life camp will call these people here pro-abortion, and people in the pro-choice camp will call these people anti-abortion, but it's not the words that they use to describe themselves. And so the point of that is that it is important to be aware of how words are used, because they can manipulate mathematical data, they can manipulate people's viewpoints, they can manipulate how people will answer questions. And so just you as an informed person, you want to be aware of how words, phrasing, question, sampling strategies, what your population is, where are you getting the numbers that you're getting to put into your probabilities. Okay, like where is this stuff coming from? And you want to ask those questions and be aware. Not all bias is bad, but it is important to recognize if there is bias or if there is potential bias there. All right, so you should be able to, at this point, upload these notes into Focus, and that should be the last notes upload that you need to do.